But they dropped the S after a certain year.
Really?
Yeah, they stopped using the S in that language.
El Hospital.
In the whole language, just drop
In
the
the
letter.
whole language, after a certain year, they said forget the S.
What language is
And we
it?
can convert to metric.
Yes,
Just drop a whole letter.
just drop a letter, right?
It's like how they drop a letter.
So this one's gonna be fun. Look at this.
Yes.
A ln of A, would you say is equivalent to ln of A over A to the negative 1?
Yeah.
Yes? Okay, so let's get the derivative of the top and the derivative of the bottom.
Wait, what?
Oh,
No.
What's the derivative of the top? Because that's how we apply law.
1 over A.
So we're gonna get 1 over A over, get the derivative. Power rule.
It's A to the 0. Wait, no.
Derivative, not integral.
Why is it negative A? Oh, because yeah, never mind.
Power rule.
Yeah.
Yeah?
Too many
Multiply, take away 1.
Too many integrals.
Ah, derivatives, integrals, what's happening? Ah! Okay, cool, come back. So, what does this actually become?
It becomes negative A to the negative 1. I'm just.
So it's like A squared, because that goes up.
Yeah.
Is it right over
Which is
A?
just
A squared over negative A?
negative.
Okay, so then that becomes just what?
Wait, why negative A?
And then we want the limit as A approaches 0 from the right of negative, not equals, of negative A.
Confusion.
Okay.
What would that equal? Can we plug in 0 there? So we get negative 0.
What is that
Which is
little
0.
bit right there?
Huh?
The limit as A approaches 0 to the negative.
Negative A.
And negative A. And next to that?
It's a little triangle right there.
Wait, Mr. Science, how did you get AX over negative A?
I really don't
Oh,
I
that's
rewrote this, I sent it down, so I made his power negative. So I wanted him to be in the form of a fraction. No, A to the negative 1 power. Yeah? I wanted him to be in a form of a fraction, so that way I can do L'Hopital's rule, derivative of the top, derivative of the bottom.
Did you do horseshoe method for that? Or
Sure, you can do horseshoe method if you want to.
And why did you do low D high minus high D low?
I didn't do
No,
that.
I know why. But
Because I'm not doing the derivative of a fraction, I'm doing the derivative of the numerator over the derivative of the denominator, which is what L'Hopital's rule tells us to do.
Okay. And why is it negative A on the denominator? Is it negative? Like if you did like the KCO and
The only part that goes up is the part with the negative exponent.
Oh, I'm dumb.
The negatives should stay in the denominator. Okay?
Okay, I see now. Yes.
Yes? This is really like negative 1 times that, and negative 1 doesn't have a negative exponent.
Okay, I see it
Yes,
now.
no, maybe so?
Yeah.
Minor technicality, but.
I got it.
Alright, so then that would end up becoming 0 after
Wow.
we figure it out, right?
Yeah.
Minus 0,
I know, man.
minus, and then that's just negative 1. What does all this become? Does it converge or diverge? Converge.
Sorry.
Sometimes there's going to be some indeterminate forms that you cannot fix. Cannot figure out a way to figure them out. Huh? If you can't do that, your answer would be indeterminate. So like if you were to type one of those integrals in the calculator, it would give you undefined. If it gives you an infinity, then that means there's a way to fix that indeterminate part. Yeah? To become some infinity. Yeah?
Yes.
Yes? No? Maybe so?
Yes.
Okay, cool. One more?
We also need one for case 3.
One for case 3? Alright, I got you, man. I got you. This one's gonna be fun. What number is this? 4?
4.
It's about half a page.
Oh, it's gonna be after.
Feel about one of those 5-star notebooks. Alright, so let's go from 0 to 3 of 1 over x minus 1 dx.
Hold up. Big part.
How do you know? It looks pretty normal to me.
At 1, there's a few little
At
birds.
1, right? Man, so we got a vertical asymptote at x equals 1, so there is a problem, right? So this guy's gonna have to be split. We're gonna have to do the integral from where to where?
Who knows?
0 to 1.
0 to 1 of 1 over x minus 1 dx. Plus the integral from
1 is over 1, 2, 3.
1 to 3 of 1 over x minus 1 dx. So now it becomes like case 1 and case 2 put together, right? Okay, cool. So let's do it.
Wait, what if we put together? How about this one? This one?
What's this guy? Where's the limit gonna be here?
From the right.
The
The left. I'm
limit,
sorry. The as B.
As B
the limit as
approaches
b
Approaches
with 1
1
from the
from the
left,
left.
from the left
the
of the
integral
integral.
of 0 to B,
Beautiful.
1 over x minus 1 dx.
1 over x minus 1 dx.
Yes.
Okay.
Plus
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 the limit
As
at B approach.
B approaches 1.
Wait, this is how
A
you
approaches
a approaches 1
from the left.
from
Right,
the left.
right.
From the right.
From the right.
Right.
So we use left on this one, that one should be right, right?
Yeah.
If we use right on this one, that one should be left?
Wait, this is like yesterday.
Yes, this,
No.
stop, this is right.
You gotta
This
use
is
the right one for
This
the
is
right
right.
Okay, cool. Of the integral from where to where?
8 to 3.
1 over
A to
x
3.
minus 1.
Beautiful, right?
Yes.
Okay, cool. So can we integrate this guy?
Yes.
Yes?
Yes.
Alright, so let's integrate him. What would we get?
Oh, yesterday was infinity. Now it's the actual number.
ln absolute value of x minus 1, evaluated from 0 to b, limit as b goes to 1 from the left. Plus, this one's gonna be ln absolute value of x minus 1 again, evaluated from a to 3. Ah, I forgot to put the limit here. And a approaches 1 from the right. My badness. Good? Plug in the b, so we get ln absolute value of b minus 1 minus ln of 0 minus 1, which is negative 1, but we get the absolute value of it, so it becomes positive 1.
I'm just kidding. I'm not going.
Of course.
Thank you.
Oh,
Yes, no, maybe so?
Yes.
Minus
No?
plus.
Plus.
No.
Psych.
No.
Don't forget to put the limit.
Dude, it's B and A, not A and A.
Don't forget to put the limit over here. This one's gonna be ln of 3 minus 1, which is this ln of what?
How do you get that number?
2
2 minus ln.
minus
Absolute
ln
value of A.
absolute value of a minus 1.
Yes.
So far so good?
Yes.
Perfect.
Alright, so now we gotta do these two limits. So this first one is only gonna affect this part, right?
Woman.
Sorry, shouldn't have used that one. Sorry. So he's only gonna affect him, right? So let's see if it works by just substituting. 1 minus 1? 0 ln of 0?
Not good.
1.
Negative infinity?
Yeah.
Sure?
No.
Approach is negative.
Or should we pay attention to the graph?
Why are you asking?
What does the graph of this guy look like?
It's like ln of ln of x minus 1.
Oh, wait.
He's like ln of x
But like to the right.
minus 1, so move 1 to the what?
Right.
Right.
1 to the right. So his vertical asymptote is at what?
1.
At 1, and he gets really close to him and goes that way? Yes, would you say? The ln of x graph just shifted 1 unit to the right? Yes? So could I approach 1 from the left?
No.
No.
Could I approach 1 from the left?
No.
No, that function doesn't even exist on that side, right?
So it's like
So what would we say for that limit? Does not exist, right?
Wow.
That limit does not exist, because we can't even approach it from that side.
Poor Fatima, what she's missing.
Minus what?
Wait, does it matter? Oh, wait.
Minus 0, right?
But like you can't. But
Plus
Wait a second.
ln of 2, right? minus, let's figure out what this one is.
Oh, I wonder what it is.
So, on that one, is it the same graph? We just changed the letter?
Yeah.
Yeah, it's the same graph, right? But
Yeah.
this one we're approaching from what?
The
Right,
right.
so what are we getting as we approach from the right?
Negative infinity.
So negative infinity, so it becomes positive infinity?
Okay, cool.
So
Wow.
what is the answer?
So what is this equal?
Infinity.
Series.
No, wait, impossible.
Anything plus infinity is.
Not good. Does not exist.
So this one ends up just
Not
equally
good,
does not exist. So what does that mean that this guy does?
So not
It
Eight. Diverges. Diverges.
The limit does not exist, it diverges. If the limit exists, then it has to converge.
What if-
You're getting a finite number.
I know the DNU was there would still diverge, right?
If the D&E wasn't there, yeah, it would still diverge to infinity. Is that what I mean?
Alright,
Cool?
Yay.
Got it? You get it good?
Yeah.
Yes? Alright.
Homework.
Ready for the homework?
Yes, sir.
You wanna do a little bit more exploration?
I feel like we have to be more explorative.
You wanna go back and look at some P-series integrals and see if there's some correlation between
Yes,
those
there is. There is.
and these?
I saw
Yes.
it. I saw it.
You saw it already?
Big brain, he's big brain.
Big brain.
Should we look at that?
Yeah. I can't get
So
out.
I'm just gonna do that in case some of that comes out on your homework. It's kind of a faster way of getting to the answer without having to do all this work. Okay? Did you guys get your calculators?
No.
No.
Oh, go ahead and get them real quick.
Go get out.
Ayana, can you get me one?
We have numbers.
No?
I have number 7 though.
Thank you, sir.
Can the regular Inspire do what we're about to do, or it only works on the CAS?
What's on the other one?
Whatever he does on the calculator works on.
Yeah.
Once you kill
Whatever I do on this one should work on the
your
other.
math.
Having one or the other does not give you an advantage on the.
Yes.
Actually, you're right. Alright, so if we remember back to the P-series integrals, right? What do we remember about the P-series integrals that we did? They were all from A to what?
A to infinity.
To infinity, right? How would I know if I recognized an integral that was in that form, whether it converged or diverged?
If
The
A
power on the
was-
bottom was more than 0.
So if the P was more than 0, no. What does P-series depend on?
Number one.
The number 1, right? Remember, P-series depends on the number
One.
1. So, it depended on whether it was greater than 1 or less than or equal to 1, right?
Yes.
So when did it converge?
More than one.
Greater than 1. When did it diverge? Less than or equal to 1, right? But that was when we were approaching what?
Infinity.
Infinity, because we had a graph that looked like this. And we were talking about what happens as I get further and further this way. I'm looking at this bounded space. Okay. What we're gonna look at today is P-series also types, but now we're going from 1 to 0. So now we're talking about the space that's where?
On the top.
Closer to what?
0.
Closer to what?
Oh, the y-axis.
The y-axis, right? Which is another infinite discontinuity, because I cannot divide by what?
0.
By 0. You understand? Yes, no, maybe so?
Yeah.
Alright. Now we're gonna try and see if we can figure out when it converges and when it diverges when we're looking at those particular cases. Because that might also help us answer questions a lot faster. Especially if it's just divergent, right? Boom, just diverges, finished. You don't have to do any integral, you don't have to do anything. Just tell me it diverges.
Yeah.
Cool? Multiple choice, yes.
You wish.
So let's do the integral from point 0,1
Oh.
to 1
Wait.
of x to the negative 1/3 dx. Type that in your calculator and tell me what we get.
We get converging towards infinity. I'm just kidding. No, it's
Shift plus.
Ebony.
Shift plus is the shortcut for the definite integral. And then you can just delete if you don't want the definite integral.
What? We'll do that part there.
Huh?
Because you're saying.
Cool, shift plus. Shift minus is for the derivative at
1.43037616175.
1.430?
Yeah.
Yeah.
Alright, so let's get closer to the 0, because that's where the vertical asymptote is. So let's go 0.001.
Okay.
What is that gonna give us?
What's your still alive?
1.485.
1.485.
So far.
So do you think it's gonna diverge?
Converge. Let's
Let's get closer, so 0.00001.
Okay.
4 zeros and then a 1. Is that pretty close to 0?
It's pretty damn close to zero.
Pretty close.
Yeah?
I will go back.
1.497.
1.497?
Correct.
Oh wait, it's getting to 1.5.
Less.
Huh?
Huh?
You got 1.499?
1.47.
I just put a bunch of
What?
zeros and I go.
Oh, wait.
Forgot a zero.
So what does it seem to be converging to?
1.5.
1.49999.
Seems to converge
See?
to